Nitrium, if you're using Grignard, right? Grignard makes an attack to this carbon of the nitrile, and then that makes an enene. Enene hydrolyzing enene, you get a ketone form, right? Nitrile could be a good source for making ketone. Nitrile, using a diabond, right? That this hydride makes an attack, makes a carbon nitrogen double bonds, and then water basically break it up, you make an aldehyde. So carbon chain of the Grignard makes a ketone, hydride dipole makes an aldehyde. If you're using lithium aluminum hydride with the nitrile, it becomes just a primary ring. You will never get aldehyde, you will get the ketone. This is a reaction that we haven't talked about it yet, but I just want you to know. If you hydrolyze it, what it means is that you have to put in acidic water to heat it up. Then eventually nitrile can become carboxylic acid. I mean, it's mechanically we discussed it. So nitrile, you can think about that as a very good source of making a variety of different organic functional groups. Ester here, right? Esters, if you're using a diabond, then low temperatures, then you can make an aldehyde. If you're using ester, but if you're using lithium aluminum hydride, you're going to get the primary alcohol. You will not get this, you get the primary alcohol. I mean, acid chloride, I mean, I probably can't connect another arrow there. You can use a primary alcohol, oxidize it to a carboxylic acid, and then dilute chloride and prepare those things. It's all connected, by the way. But if you get the acid chloride, and then you are using this hydride, very, very weak hydride. I'm talking about very weak hydride, like a triketoxy aluminum hydride. And this hydride replaces the chlorine only once, makes an aldehyde, but these things are not reactive enough to touch that, so it just stops there. So that you can use to make an aldehyde from the acid chloride. That things I already told you, you can make that from the carboxylic acid using thionyl chloride. If you're wondering where the carboxylic acid can come from, that can come from alcohol if you want to. There's a variety of ways you can make carboxylic acid. Acid chloride can be used to make a ketone too. That's the reason we just talked about. The diethylcuprate deliver the carbon chain to the replacing chlorine, but it stops there because the Grignard will reduce the tertiary alcohol, but diethylcuprate deliver only once, and then it just stops right there. So that makes a ketone. I think that's the acid chloride, the lithium aluminum hydride will completely reduce everything to the primary alcohol. If you're using Grignard, the acid chloride, then two Grignard reacting with it, then you get the tertiary alcohol. See, all the reactions that you know can come back and make this slide very, very complicated. You have to know every step of this slide. Not just product, also about the mechanics as well. So that is what you are facing from now.